Hi there, and welcome back. So, in this video, we will be learning how to calculate the formal charge of an atom. So, in an isolated free atom, the number of electrons associated with that atom is simply the number of its valence electrons, which we can determine using its group number. For example, the number of electrons associated with carbon is 4. Right, so if we draw the Lewis structure for carbon, it will look like this. So, likewise, for aluminum, the number of electrons associated with a free, isolated aluminum atom is 3, because it has 3 valence electrons. So, if we draw the Lewis structure for aluminum, it will look something like this: 1, 2, 3 electrons around it. So, however, on the other hand, when an atom is in a molecule, the situation is a little bit different. An atom may not exhibit the appropriate number of electrons when it's in a molecule. And the appropriate number of electrons are the number of its valence electrons, right? So, for example, the appropriate number of electrons for a carbon atom will be 4, whereas the appropriate number of electrons for an aluminum atom is going to be 3, because aluminum has 3 valence electrons and carbon has 4 valence electrons. However, in a molecule, this may not be the case. In a molecule, an atom may or may not exhibit or sort of act like it has 4 or 3 electrons. So, when an atom exhibits the appropriate number of electrons, it has a charge of 0, because it has the same number of electrons as it has protons inside of its nucleus. Therefore, the positive and negative charges cancel each other out, giving it an overall charge of 0. However, in a molecule, atoms are covalently bonded together, meaning its electrons are shared. And because electrons are shared in a bond, we have to divide the electrons in a bonding pair equally between the atoms forming the bond. Since electrons in a bond spend time around both atoms, for this reason, we say that atoms don't exhibit the appropriate number of electrons in a molecule. The atom will thus exhibit a different charge, which we call the formal charge. So, to calculate the formal charge, we use this formula. So, the formula to calculate the formal charge, so the formal charge is going to be equal to first the total number of valence electrons, right? So the total number of valence electrons, which we can determine using that atom's group number. Then we're going to subtract the total number of non-bonding electrons. So the total number of non-bonding electrons. Non-bonding electrons, and then we're going to subtract from that 1/2 of the total number of bonding electrons. So 1/2 the total number of bonding electrons. So this is going to be our formula to calculate the formal charge. So we're going to need the total number of valence electrons, which is also its group number. And then we're going to need the total number of non-bonding electrons, right? And then we're going to need 1/2 of the total number of bonding electrons. So again, the reason why we subtract 1/2 of the bonding electrons is because electrons are shared between atoms in a bond, so we divide them equally between them. So therefore, each atom will get only half of those electrons. And typically, in order to accurately determine the number of non-bonding and bonding electrons, it's convenient for us to draw the Lewis structure of the molecule. For more information on how to draw Lewis structures of small molecules, check out my other videos. So now let's do an example. So for our first example, we have the molecule athenium, whose chemical formula is C2H5. Right, and this is going to be athenium. So let's try and find the formal charge on each atom in athenium. So the first thing we want to do is, so let's draw the Lewis structure of the molecule first. So for step one, we count the number of valence electrons. So athenium has 2 carbons and 5 hydrogens. So we draw the Lewis structure of each atom to get a picture of the total number of valence electrons. So we have 1 carbon, which has 4 valence electrons around it because it's in group 4. Another carbon, which also has 4 valence electrons. And then we have 4, actually make that 5 hydrogen atoms. And each hydrogen has 1 electron. So therefore, if we count up the number of valence electrons, we have 4 plus 4 plus 5, which gives us a total of 13. However, athenium is an ion, right? Athenium has a positive charge, right? We call this a polyatomic cation, right? Because it has a positive charge. So because the athenium molecule has a positive charge, right, we have to subtract an electron from the overall total, right? So in total, we have 13 electrons. But since athenium is a positively charged ion, we have to subtract 1 electron from the total, and that gives us a total of 12 electrons to account for in all. So, and this is because the protons in the molecule remain the same, and whereas because the electron count decreases by 1, if we take the difference between the protons from the electrons, the overall net charge is going to be positive. So that's sort of the reasoning behind why we say that this charge is positive. So next so for our next step, we combine the atoms that form more than 1 bond together. So So therefore, we want to combine the two carbon atoms together, right? So we take the two carbon atoms, we draw them in a way in which they share two electrons, right? Because this is what a covalent bond is. And then we fill in the rest of the Lewis structure. Right, so this is going to be our two carbon atoms joined together. And so now, for step 3, we add the hydrogen atoms, prioritizing atoms with the most unpaired electrons. So, since both carbon atoms have 3 unpaired electrons, we simply just add them one carbon at a time. So let's take our hydrogens, our 5 hydrogens, and then add them to our carbons, one carbon at a time. So this is our 3rd hydrogen, our 4th hydrogen, and then our 5th hydrogen. So finally, for our final step, we pair any unpaired electrons so that each atom achieves an octet, or in the case of hydrogen, a duet. In this case, the carbon on the left has 1 unpaired electron. However, since our molecule is positively charged and has 12 valence electrons in total, as we calculated earlier, we can remove this unpaired electron to give us a total of 12 electrons. So we can go ahead and sort of delete this last electron over here. Right, so this is going to be the overall Lewis structure for our molecule. And then we can go ahead and add these 2 brackets on the side, and then add a plus sign in the top right hand corner to indicate that the overall ionic nature of our molecule, right? This indicates that our molecule overall has a positive charge. So now let's use our formal charge formula to find the formal charge of each atom in athenium. So let's start with the leftmost carbon. So for the leftmost carbon, which is going to be this carbon right here, to find the formal charge, right? The formal charge of this carbon is going to be equal to the total number of its valence electrons in a free isolated atom, which is also going to be the same as its group number. So that's going to be 4. And then we're going to subtract the total number of non-bonding electrons, right? So the total number of non-bonding electrons for this leftmost carbon is going to be equal to 0, right? Because all of this carbon's electrons are participating in covalent bonds, right? So there's no free electrons hanging around on this carbon. And then finally, we're going to subtract 1/2 of the total number of bonding electrons, which is in this case is going to be 1/2 times 6, right? Because the total number of electrons participating in covalent bonds for this carbon is going to be 1, 2, 3, 4, 5, 6, right? So now, if we do the math here, the total formal charge, right, the sum, or rather the difference of all these numbers is going to be 4 minus 0 minus 1/2 of 6, which is 3. So that gives us 4 minus 0 minus 3, which is just going to be 1. Right? So therefore, the formal charge on this carbon right here is going to be +1. So to indicate a +1 formal charge for this carbon, we just add a plus next to this carbon, right? And so that's going to be the formal charge of this carbon. So now let's find the formal charge of this carbon over here, right? So let's write carbon 1 over here, and now let's find the formal charge of carbon 2. So the formal charge of carbon 2 is going to be equal to the total number of valence electrons, right, which we found out before to be 4, right, because carbon is in group 4, and then we're going to subtract the total number of non-bonding electrons, right? So the total number of non-bonding electrons is going to be 0, right? Because every single electron in this rightmost carbon is going to be involved in a covalent bond with either this carbon or these hydrogens. So we're going to write a 0 over here, and then we're going to subtract from that 1/2 of the total number of bonding electrons. So because we have a total of 8 electrons participating in a covalent bond for this carbon, it's going to be 1/2 times 8, right? So now if we do the math, right, if we take half of 8, that's going to be 4. So this is going to be 4 minus 0 minus 4, which is just 4 minus 4, which is 0. So the formal charge of this carbon is going to be 0, right? So therefore, it's going to have no formal charge, right? This carbon is going to have no formal charge on it. So we're not going to write anything next to this carbon. And finally, for each hydrogen, right, if we want to find the formal charge for each hydrogen, we're going to find that the formal charge of these hydrogens is going to be equal to 0 for each one of them, because so let's find, so if we use the formal charge equation, right, and let's write hydrogen down here, right, the group number of hydrogen is 1, right, and then the total number of non-bonding electrons is going to be 0, right, because all the electrons in hydrogen are involved in some kind of bond, right? So that's going to be 0, and then we're going to take 1/2 of the bonding electrons, right? Since hydrogen only has 2 electrons, and each of those 2 electrons are involved in a bond, we're going to say that it's going to be 1/2 of 2, which is just 1. So this is going to be equal to 1 minus 0 minus 1, right, which is just 0. So for each hydrogen, the formal charge is going to be 0, right? They're going to have no formal charge. So with that being said, thank you for watching, and have a great day.